Okay, let's see how you did. We have an ln x here, so we're going to call that u right away. And since we did, this has to be our dv, x dx. Now we take the derivative of ln x, and that's 1 over x dx. And now we're going to integrate x dx to get v, and that becomes x squared over 2. All right, now we apply it right into here. We have u times v. So we have ln x times v, which is x squared over 2, minus the integration of v. V is x squared over 2, du. Du is 1 over x dx. Okay, bring this to the front. X squared over 2 ln x, bring out the 1/2, integrating, we have this cancels out, dx, and our answer is x squared over 2 ln x, and you had minus x squared over 4 plus c. Very good. Okay, let's move forward. We're going to go on to another problem. And in the past, we have seen this right here. Let me show you. If we have y equals ln x, we know the derivative of y is 1 over x, okay? If we integrate 1 over x dx, then we know the the integral is going to be ln x plus c. What we don't know yet is how to integrate ln x by itself. Okay? Now we're going to do this where we're going to assume x is greater than 0. All right? So we're going to apply the same thing, what we've been doing, integration by parts, uv minus the integral of v du. Okay, so off to the side, u equals, du equals, v equals, and dv. Okay, so u, we're going to let be ln x. So what does that leave for dv? dv is just going to be dx. And you can think of it as 1 times dx because we're going to be integrating that. Okay, so we take the derivative of ln x, we get 1 over x dx. We integrate dx, and that's just x. Okay, so now we apply that u times v. U is ln x times v, which is x, minus integration of v, which is x, du, times 1 over x dx. Okay? All right. Now what I'm going to do is I'm going to bring this x to the front. So we have x ln x minus, well, this is just 1, right? So if this is 1, what's the integration of 1? Well, it's just x, and then plus c. All right. Now this you need to memorize. The integration of ln of x dx equals that right there. We're going to use that a lot in what we're going to be doing for what we're going to solve now. Okay, so let's do an actual problem. We're going to pretend you've got that memorized, all right? So here's a problem. Okay, we're going to integrate from 1 to 2 of ln of x dx. Well, shoot, we have this memorized, don't we? We know the integration of ln of x is x ln x minus x. And we're going to take that because we have parameters now from 1 to 2. See how easy that is? Okay, so we put the 2 in there. 2 ln 2 minus 2 minus parentheses 1 ln 1 minus 1. All right, let's keep going. 2 ln 2 minus 2. Well, what is ln of 1? ln of 1 is 0. Remember, if we have a graph, this is ln of x. Okay, and this is 1 right here. Ln of 1 is 0. So this is 0 minus 1. And what are we doing? Since we're going from 1 to 2, we're actually looking for the area under that curve. Okay, so we have 2 ln 2. Here we have a minus 2 and a plus 1, which gives us minus 1. And then we can figure out what that area is, approximate it, 0.386 units squared, or square units.